Welcome, my fellow mathematicians and teacher. I'd like to take this beautiful moment to teach you guys a little something. You see, while I was swinging away in the dirt, I noticed incredible capabilities. When you look here at this T, you know what I notice? I see a polar equation. But not just any polar equation, a rose polar equation. So I'd like to take this moment to teach you guys about rose petal polar equations. So, rose petal polar equations. This is the just the basic concept of what they look like. As you can see here, this one's got 5 petals right here on my T. That's a good one to swing at. But there's 4 different groups they can be broken into. And here's the base, here's like the main formula for it. You can either have a sine or a cosine. But these ones are special because they can be even or odd. And the n here would be the even or odd factor. So as you can see here, these ones are in cosine. If they were in sine, they would be tilted 45 degrees. Just a little off, but they would have the same concept. The ones with are even, these are the even ones. Obviously, they have an even amount of petals, right? And if these are the odd ones, that's a good thing to remember. So, a cosine or a polar petal equation where n is odd will look something like this, like I said. And the important thing to know about the amount of petals is n. So however much n is, whatever n is that's going to be the amount of petals. So if we look here, n is 3, that's going to be the amount of petals. Here's my little demonstration on what it should look like here for you. That's how you would graph it. And if you look here for a moment, it stops. What is it doing now? Well, it's actually it's going over. So as you saw, it's going to go around, and then it's doing it again because it does it twice because it's odd. It's just the way. And next, I'd like to introduce you guys to the even one, where n is even. This one is a little tricky because you may say, oh, n, it's an even number. That's crazy. That's the amount. But no. It's 2n. It's tricky. You see here, it says n is 8, but there's 16 petals. That's a funky one. And this one always has symmetry. By the proof of math, we know that it has symmetry across the polar axis. But by proof of observation, we can see that it has symmetry in both the polar axis, the pole, the polar axis, the pole, and theta equals pi over 2. So I'd like to show you guys my demonstration here. Once again, it'll continue that pattern where it goes back over to the other side. That's the beauty of this thing. So there, ladies and gentlemen, is where I'd like to end my little thing. I want you guys to pay attention to these beautiful rose petals in life. Because come spring, you'll see them all over. I'd like to start the first one.